Welcome to San Francisco if you're not from San Francisco, and welcome to the near Electric Capital San Francisco Compute Useful Agent Hackathon today. My name is Michael. Your idea, bring it into fruition. Oops. All right, back in action. So we're here to help you bring your idea into fruition, help you while you're building on Near, and support you through a variety of different programs that we have. You're going to help pass over to Cameron for an introduction too.
Hey everybody, how's it going? My name is Cameron Dennis. I'm on the Near AI team, and today we're going to be unpacking how to build useful agents. I'm assuming all of you guys are familiar with agents, but a lot of you probably aren't as familiar with useful agents because there's not a ton of useful agents out there today. So let's change that today. And just for some background, I'm on the Near AI side where we're building a agent hosting network, an assistant, and pass it off to Michael, and I'll get back to some of the support that Near AI team can provide.
And just quick show of hands, who in the room has built an agent before? Awesome, so we got a lot of good experience here today. And I know a few people are going to be looking for teams. Quick show of hands, if you happen to be looking for a team, throw your hand in the air. Awesome, okay, so you guys connect, please. At the end, we also have a Discord, so if you miss somebody raising their hand, go through the Discord and you can connect in there. So anyway, let's go ahead and dive into it. What is a useful agent? Soon we'll hear from an esteemed set of panelists to dive into this, but just from a high-level perspective, we see agent development as a ladder where you really have to walk before you can run. And so you can see here the initial phase of creating an agent starts with a basic prompt and a computer being on. All right, okay. Next, most Twitter agents that we see are created through some fine-tuning, so it gets a little bit more sophisticated. You get unique behavior, personality, and some specialization. But then really what makes a useful agent is here on the right-hand side, the verifiability and self-improvement. And so that's really what we're going to be looking to today. What you guys build can become useful agents. And so our agenda is a two-day event. Today we're going to start off with the panel after us from where we will hear from Ken from Electric Capital, Ilya from Near, and then Adam from Anthropic, and Evan from SF Compute. We'll have lunch in the middle. And along the way, when you guys do need to step away and have a bit of a break, we will have a variety of workshops from the bounty providers and our partners going throughout the day. And the agenda is going to be in the Discord too, so you can keep on track of that. Very important part of the agenda to remember is tomorrow at 12 p.m., that's when you have to have your project submitted. So if you're building today, make sure you have it in by then. And then after that in the afternoon, we'll have the judging and the announcements. So please scan this QR code right now to get into the Hackathon Discord. We'll wait for a minute. I'm not going to go to the next slide until I see everybody's phone up. But this is where you'll want to spend the time today. If you do miss this QR code or you lose it or whatever, come back to reach out to one of us at the Near team. We'll get you back into it.
We'll also drop it in the Luma right after this.
Even better. Thank you, Cameron. All right, I see a couple of phones up. I think we're good. All right. And with that, I'm going to pass it over to Cameron to get into the fun stuff.
All right, so I'm assuming everyone here likes money, and so the first prize is $5,000. Electric Capital and other organizers were really generous. Oh, I guess I'm winging it. Really generous, so first prize is $5,000, second place is $3,000, and third place is $2,000. This is just for general bounty, just general winners, and then there's sponsor-specific bounties. And so if you go to the Luma right now, you can see the sponsor-specific bounties. They're all there. You can bounty stack. So if you want to, let's say, leverage Xtrace for their encrypted memory and like database, you can do that and deploy via like follow network and near and everything else. And so you can bounty stack. This is how you make more money. And so there are some technical requirements. All agents built need to be deployed to the Near AI Hub. This has nothing to do with crypto, but you will need a wallet in order to log in. So hit me up for a funded wallet. It's super, super easy to make one. You're literally just going to click a link, and there's going to be money in there. It's pretty all abstracted. Hit me up. I will drop, again, my Telegram or phone number in the Luma. So definitely check that out. And it's super easy to deploy. It's Near AI Hub supports TypeScript and Python, so all those agents that you've built can easily just be hosted in the network. And so all you got to do is literally click that, press near, press deploy. It's easy. And lastly, again, please, please, please submit by 12 p.m. tomorrow. You can submit before. And I also want to flag, you can submit an agent that you've previously been working on as long as you provide some sort of benchmark and evaluation framework to prove its usefulness. This is the useful agent hackathon, not the useless agent hackathon. So you need to provide that sort of framework. Now, I will say these benchmarks are going to be use case specific, so it is up to you to prove how useful it is. It's, again, pretty straightforward, but make sure to submit tomorrow before 12 p.m. This venue is open 24/7, and so you can stay here all night long, and I will be here, but maybe not at 3 a.m. So, but you're welcome to stay. There is, by the way, I don't know if a lot of people have actually started walking around, but if you turn the corner, there are a bunch of rooms that you can pretty much camp out in. And those rooms have monitors in them. Highly recommend picking a room and hanging out there. You could also obviously hang out here as well. So make yourself at home. This whole floor is available, except there's one little area that says staff only. It's very clear. Don't go there. And besides that, Michael, where'd you go? Hi. Is there any other slides? No more slides. Great. Well, then, without further ado, would love to invite the panelists up. Come on over. Again, this would not be made possible without Electric Capital. They are, the best VC firm in the world. And yeah, want to pass it off to Avichal for introductions.
Thanks, I appreciate it. Hey, everybody. Okay, we're going to pass some mics around, I guess. We have 2 mics? Okay, cool. I will try to talk to Lise then. Thank you, everybody, for being here. Maybe we can do quick intros on people's backgrounds. My name is Avichal. I'm one of the founders at Electric Capital. Yeah, very excited to talk to these guys. Kick it off.
I'm Ilya, co-founder of Near and Near AI. AI researcher before, back in the day, now AI enthusiast.
I have a feeling everybody's going to be like too humble, so I'm going to do like secondary intros on everybody. I'm pretty sure people here should know, but Ilya is one of the authors on the Transformer paper, Attention is All You Need paper. Extremely thoughtful guy. He's been thinking about this stuff for many, many years. And there's an amazing backstory on Near, if we have time to tell it later, that we could tell it about how it originally started as an AI company, and then they had to solve a bunch of blockchain problems to actually build the thing that they wanted to do, and then 5 years later, we're able to come back to actually solve those problems. So anyway, I have a feeling these guys are going to be way too humble, and so I'm going to give you extra color. So don't be humble. If you're humble, I'm going to have to do your intro for you.
I'm Evan, and I'm the greatest product person in the world.
Nice job.
I'm also your mayor. I'm cut off now. Whoa, oh, it actually works again. Okay, cool. Yeah, I'm the mayor of San Francisco. Nice to meet you. I run a company called San Francisco Compute. We sell GPUs, I guess you could say.
Hi, I'm Adam. I used to work at Facebook. I worked on React for a really long time. I worked at Robinhood for quite a while, and quite recently at Electric Capital, which was awesome. Now I work at Anthropic. I'm the manager of the Claude Code team. So if you've used Claude Code, and I hope you have, I hope you will today. Yeah, that's what I work on.
Okay, we'll keep going. Yeah, Adam was very senior and had a hand in creating React. That's what his team created, in addition to things like Yarn and I'm blanking on the other stuff right now, GraphQL and a bunch of cool stuff. A lot of the open source stuff that Facebook has done over the years, Adam helped create and ran big teams at Robinhood. And okay, let's kick it off. Maybe we'll just start since given the audience of builders and hackers and people who are gonna. AV issues. Okay. So, hey. Oh, Cameron, is it working now? Okay. Okay, I'm just gonna yell. When you think about like general purpose LLMs right now, and just how powerful they've gotten, how do you think about how startups and early builders, like when they're getting off the ground, should be thinking about the trade-offs between these like larger capable models and just using those out of the box versus taking something that is maybe less capable but either more performant or more cost-effective from a cost perspective, or maybe even try to customize things that are a little bit lighter weight and use them in custom ways versus just waiting for the more the sort of larger foundational models to just get better. Like, how do you think about some of these trade-offs with the big LLM models versus customizing?
Yeah, I can start. I think right now you effectively should start always with the biggest, the smartest, and the most expensive, naturally most expensive model, and effectively try to build your product. And that gives you the understanding, is it even possible to do that? And also you, as part of that, will build evaluation, we'll build benchmark, we'll understand like where are you on the kind of like how, how stable, how good this outcome is. Then from there, if you're actually productionizing this and putting this in front of users, that's when you start thinking through kind of different trade-offs. And obviously, smaller models are also faster and cheaper. And so if you have a very specific like niche where you want to get to, right, you can start effectively, few different versions of distillation, effectively, of the big model doing your specific use case into this. But that should only come after you actually validated that this thing actually works. So for me, it starts with the biggest model, get the product working, understand quality you can actually get out of the like best model, or use 3 models, Claude, OpenAI, and DeepSeek at the same time. Get the ensemble going and see if you can get the product going. And then after that, you're like, okay, cool. Now we have first 100 users using this, it costs some real money. Let's start distilling it. That's when you actually like, okay, first investing fine tuning. Maybe you actually distill from traces that like the bigger model generate into a smaller model. I mean, we can discuss on those methods. Like, it's effectively the progression when you need to lower the costs at like higher scale of user base.
Can you repeat the question, then I will repeat it to the audience because you were quiet.
Sorry. Yeah. Just saying, how do you think about this? So there's like a model dimension to this, and then there's like a GPU cost dimension to this. Both, if you're going to do any kind of fine tuning, or if you're going to do any sort of training, but also just from an inference perspective. And so, how do you, when you're just getting off the ground, what advice do you have for startups as they think about their GPU costs to just run these things? How much should they be worried about cost optimization versus just use like the biggest, best, most expensive thing to make it work?
So let's say you're building like an engine in a car, and you're in the 1920s. Cars were kind of shitty in the 1920s, and they didn't go very far, and they didn't go very fast. And so if you had a really good engine, you really needed to build the rest of the car in order to sell anything, because you needed to sort of squeeze out the performance of both the car and the chassis, or the engine and the chassis and the wheels and the everything involved in the car in order to make it go faster, because that was the thing that people cared about, because the car went like 20 miles an hour. But once the car starts to go more than like 120 miles an hour, your customer doesn't care about the speed of the car. So if you have a really good engine, you're kind of like your really good engine doesn't matter anymore, because it produces a car, or like your really good engine doesn't matter anymore because your customers start to care not about the speed of the car, but by like leather seats and a radio and stuff like that. And so what that means is that for any technology, there's like a performance curve. And as you start to go on that performance curve, eventually you overshoot the customer demand, and then they don't care anymore, and the customer demand shifts to some other thing. And so if you're building a product, you want to be the other thing. You want to allow the engines to get faster, which is like the models, and sort of not at all care in any capacity. This isn't really answering your question, but it does.
Yeah, it's a good Yeah, so how do you, like, at what, maybe a different way to ask the question is, like, at what point do you think startups actually should start caring about their GPU costs? Or how should they start, like, does it even matter? Like, if you just charge your customer more and you're like, whatever, throw dollars at it and, like, the problem will fix itself? Or, like,
yeah,
who starts to care and when do they start to care?
I think it is when you cannot capture the value long term, basically. So there's like a bunch of companies out there who you will see exciting numbers from, and they'll say like, oh my gosh, it's like the fastest company to 100 million ARR of some sort. And what is actually happening there is they just have like really high top line revenue, and then they pay a lot of their money to the underlying model layer or the underlying compute layer. And so their margins aren't that great, but their top line number is really high, and so people get really excited about them. And this is a fine and okay thing, so long as they can capture the margin later on. And for some people, I totally think they can. Some sort of AI model layer companies pay a lot of money to their underlying model provider, and then the model gets cheaper, but they retain the customer. So it's not so much about like how much you're paying, as long as your customers are charging you, but probably more about like what your retention is on that, and if you have any sort of like actual moat to keep your customer. Because if the model does get cheaper under the hood, and you are charging your customer a bunch, then the happy path is you can reduce the prices for your customer while retaining the same margin or a higher margin, while the sad path is you don't.
Yeah, that's a good take, actually. I dig that. I think it's a good way to think about it. Adam, maybe sort of a related-ish question to you, which is, working on Claude and working on code, working on Sonnet, like, what's your advice as for founders about how to best use these models? Like, do you think they should be trying to do anything sophisticated on top of this? There's people that try to do various forms of fine-tuning or something like that. Or do you think people should sort of just stick to like prompt engineering? Yeah, I'm curious what you think about it.
Yeah, a couple thoughts, and going back to your original question about how do you save cost or fine tuning these kinds of things. You should definitely use both the big, smart, slow model and the small, fast, cheap model from whatever provider you're using. So for Anthropic, that's Sonnet and Haiku. There are definitely always use cases for the smaller, cheaper one, especially summarization, things that don't really require like thought. So when you're building an agent framework, that's an important part of it, and also like kind of using side chains to conserve tokens and deliver summaries back into the main conversation. So that's one place you can really be clever, and I think you can save cost and speed things up. I really think fine tuning is a dangerous thing to do. It just, like, the model capabilities are moving so fast, it's really hard to win on that one. It's expensive, it's difficult, you can easily kind of mess up the model, actually, and in 2 months there'll be something that's much smarter that might just be able to do what you're trying to do anyway. I think the thing people tend to sleep on, and this is not news, but I want to emphasize it, is the prompt engineering. That is something that, like one thing that really surprised me working with researchers at Anthropic is how carefully they go over the prompts. No spelling errors, no grammatical errors. Like ask the model, hey, why did you mess this up? Can we go back and fix your prompt so that you wouldn't? These things actually really improve accuracy. You would be really surprised, I think, how much you can get out of prompt tuning. That is the biggest lever with these models, I would say. And it's really hard to write really clear English. It's like even harder than writing a good computer program. But that's what you have to do.
Yeah, that actually dovetails maybe to a sort of related question is, okay, well, if everybody has the underlying access to the same models, how do you really win and differentiate as an early stage company trying to build a product and get it out of the ground? And so prompt engineering certainly could be one, which is you may just get more out of the model. But I think, Ilya, you have some thoughts on this.
Yeah, I was kind of building on the analogy. I wanted to ask you, like, how you see, given you've seen like few previous cycles of the technology innovation. I'm curious. From my perspective, I mean, there's few things that I think are important to understand. One is I think we are in a fundamentally changing environment, right? And I actually think that AI is a last technology wave, right? Everything else will be built on top of this, probably by the AI itself, and Mike will be kind of on this and more in like devolves state. And so I think there's a very interesting 5-year opportunity right now that exists where kind of while the overall capabilities are ramping up, kind of there's opportunities to solve real problems right now for real people. And that is where the most kind of differentiation is happening, right? Like as a startup, you effectively the more narrower you can effectively address some specific problem, like that is actually what people are willing to pay for right now, right? Like this fast-growing revenue startups are mostly coming from like, hey, cool, we gotta fix your like supply chain analysis, because people are right now taking picture, like right now it's all paperwork in a port, and like somebody needs to take a picture, and we can OCR now this, and we can crank the quality of that OCR model with Mistral, and then we're gonna feed it into Claude, and then we feed that into the OpenAI, and then we get the response, and then we use some protocols to route the data, right? So like it's really about like this creative solutioning that solves a specific problem. But I do think while that is a very clear opportunity right now, I'm actually curious that's kind of the question. I'm curious because I think a lot of this is gonna get more and more undifferentiated as the foundational models are getting better, and we're getting like more and more general assistants as well that are maybe they're calling this agents and they kind of coordinating them, but like from a user experience interface, like this all gonna get more and more abstracted away. And so I do think like the opportunities right now is like next 2 years, and then the kind of general assistants actually will become a lot more kind of themselves powerful.
I think this speaks a little bit too to Evan, what you're talking about. I guess you guys are all touching on this. It's just like there is I think there's definitely some limited moat right now in building the right interface on top of the foundational models, because there are a bunch of modalities of just using these things, which is like, well, what context do I need to see while I'm doing the thing? And so this is why like Cursor or Cloud Code can exist on top of a general model, and they're just like a different thing. That's probably a lot of different use cases and a lot of different verticals. Around like data loops, I think is the right one, which is like I think there are lots of data loops that you could build if you retain customers, and so retention ends up being really, really important. If you actually build a retentive product, I think you have a shot. But to your point around AI eventually like building everything, yeah, I mean, in the limit, you play this out 7 or 10 years, you could totally imagine, talk to whichever Anthropic model is the dominant model at the time, and what it does is it generates the UI for you on the fly, right? It's smart enough to know that like given this context, here's the UI that you need, and system generate an UI for you on the fly, which is kind of think about.
Also, go and find the right data.
Yeah. Yeah. It's kind of a wild thing to think about, and so yeah, it's something we think about from the venture side a lot, because it really starts to throw into question like what are the actual moats in a business, if like the underlying intelligence is so strong and so fast. What does that mean for like all the layers on top of it? Like I personally think most SaaS software is probably just dead, Like I think it has a very limited shelf life here. There's like a couple of years, and they're gonna have to adapt pretty dramatically. The categories that may have more defensibility, and these are sort of like non-technical, I think, are things like where there's a human that has to be involved in the purchasing decision. So like government software probably ends up being like way more valuable because the government is not going to just like let an AI decide to buy the software or like let some rando decide to buy the software. Yeah, maybe if Elon's president, maybe. And so yeah, it like really shifts the. I guess maybe another way to put it is like I think software, certain categories of software, and arguably most software, starts to look a lot more like what direct-to-consumer businesses look like today, which is like the supply chain is the supply chain, and you can find the factory in like China to produce the thing, and if you have like the marketing and the brand and the distribution in front of it, like you have a real advantage. I think software starts to look a lot more like that.
Yeah, I mean, and just like to actually counteract the marketing part, and because again, if you assume like, I mean, we just have an AI that runs on our device, like our AI will make the purchasing decisions. Like there's no marketing that will affect the AI. Like, I mean, this is an interesting question. Like, yeah, what is it? You know, SEO optimization of AI will look like, but you know, as these models are getting better, and like we are, I mean, I think the research is working on actually trying to prevent kind of the biases, etc. I think the position we take with Near AI is actually that the agents are effectively the new apps, right? Where this is not the agents that are gonna like that are running inside the context of the user, but actually agents that are running in the context of other entities, right? Services, factories, you know, pharma companies, etc. And your AI is actually now communicating with them, creating, you know, figuring out with them how things are getting done. And so they obviously capturing value because they actually are they're a counterpoint to your, you know, your intent. And so they're actually executing that.
So maybe building on that, question for everybody. You know, I think when people talk AI these days, they're often talking about LLMs, these sort of foundational models that are built in a very specific way. I'm curious where you guys see applications for this stuff that are very high leverage, high impact, like out of the box. This stuff is going to be awesome, and people should just start building. And then conversely, where do you look at this architecture and stack all the way down? Because there are a bunch of assumptions made all the way down to like the GPU layer, and you sort of look at it and say, you know what? Actually, there are categories of problems that the current sort of popular approach is not the right approach for out of the box. There's actually a lot of opportunity in going and doing something very different in those areas. So yeah, maybe curious if you guys have areas where you're like, yeah, out of the box, huge opportunities in these areas, and actually like out of the box, these are not good applications for this sort of a technology. Adam, you have thoughts?
I'll kind of pick up on the point that we were talking about before, which is like, I mean, I work on Claude Code, so I kind of voted with my feet. I think the main application right now is for coding. And I think when we talk about differentiation and how you can build something great, you have to take advantage of what the AI can do to accelerate and like enrich the code that you write. And I think like handling edge cases in your product, like tolerating new orders of magnitude of complexity in the software that you build is probably like the biggest lever right now, I think. So like, you know, I think software is going to get a lot more complex, a lot more tailored to use cases. Like right now, you know, you go to a web page and like it doesn't work for you because you're on the wrong version of Arch Linux or whatever. And like, we're just gonna have to build support for Arch Linux now. You know, it used to be like, get out of here. What are you talking about? But I think what you'll see is like successful products will really like have really wide, you know, range of tolerating these like edge cases and be quite complex, maybe like too much more complex than we can currently understand even. As far as like, you know, some of these like fundamental things, I mean, that is something where like, I'm not an AI researcher. I don't know too much about that. I think something people try to do is like take LLMs and use them for things that you really should be building a little classifier for or a time series prediction model for or something like that. Generally a bad idea. You're going to lose to the people who know what they're doing and are just training something very specific. Yeah, sure. I mean, the one agent that I always hear about at crypto events is like the trading agent. And I just, you know, like how are you going to win with that? I have no idea. Like the AI isn't even that smart. And unless you have a data source that is like pure alpha, and it's for some reason it's better for an LLM to read it than for you to read it. I think it's a loser.
Thoughts on areas where this applies and areas where like just don't like it's just like a waste of time to try to use these things?
Like specifically on LLMs.
For clarity, do you include like VLMs, audio LMs, like all that into LMs, or?
I was thinking narrowly tailored to essentially foundational models out of the box, because that's usually what startups do, is they sort of like take the foundational models and these guys out of the box. But there are multiple modalities now to those models as well.
So I kind of think that all the agents don't work without RL. I think this is kind of like understood now as of the last month or two, but like there was this period of time in which a lot of people were trying to make like LLM agents, and they all kind of didn't work. And I think they only really start working when you have RL on top of them and you do like these really big post-training runs. That is probably actually a good thing for startups, because you can take some unique data set that you only have, or some unique use case that you only have, and you can like do your own little post-training run on top of it, and then you can get something that actually works instead of not working, and that like last 1% like totally matters for a lot of industries, because it's like the difference between a product actually working or not, and this is very distinctly different than the like, oh, there's going to be one model that will do everything. It might eventually do one everything, but if you have one particular use case, it's kind of hard for the big lab to get that particular use case into their model if it's weird or strange. But you know, that plus I think there's a whole bunch of interesting stuff that people are going to do with physics sims that like makes you work in the real world a lot better. But yeah.
I mean, I think, yeah, like, depends where you draw the line, right? Because, I mean, we were talking earlier, right? If you are trying to do price prediction, like, the transformer architecture itself is actually really good time series. It just LEM model, right? And so, but you can use all the same methods and, you know, even like doing actually RL on time series prediction is, you know, a lot richer signal even than GRPO. So it's actually a pretty good approach. But indeed, you need to have alpha. Like otherwise, you know, the model cannot like extract information out of the same thing that everybody else is looking at and come up with new stuff. Like you need some information that other people, you know, either overlooking or don't have at all. Which in crypto, you know, it's chats and Discord and, you know, potentially some other access. So there is ways potentially to augment it, but it is like you are building a hedge fund. That's important to understand. You're not building an agent. You're building a hedge fund, and like with all the things included. But yeah, I think. I mean, right now, like the principles again that underlying this are applicable everywhere. I think, I mean, the physics sims are really interesting. I've talked to somebody who's doing actually like quantum modeling, like quantum emulator of the whole, like of the, you know, equations that describe quantum state of the materials. And so you can build a model that predicts that and effectively gives you even error bounds on how, you know, how likely like its prediction is correct. And then you can use that to now test materials really quickly, right? You can like run all kinds of different molecular and compounds and see like what's their electricity, what's their viscosity, like all of the different properties, right? So now that's not an LLM at all, right? But it is using the same principles and kind of, you know, applying to a very specific. So I think it's, yeah, it really depends on the use case and kind of the application. I think the number of modalities is constantly growing, like the modalities are getting better. The videos gotten way better, like, and I think it's actually, I think people are underestimating right now because video is so much more accessible to normal consumer that like if you do a video kind of startup, like you get so much more traction because like there is TikToks and Instagrams and YouTubes to share these videos. Like there's a lot more distribution for the creators, and so it's actually like picks up way faster now than some of the tech stuff. And then on tech stuff, like usually the challenges that we've seen and we are addressing is if you go into corporates, if you go into enterprises, like you actually need to deal with all the GDPR, HIPAA compliance, et cetera, and that right now is complicated. And so what, as Near AI, we offer is actually a platform that for developers, you can just get all of that for free for confidentiality. So I think like there is also just like a practical implications of like how these models are used and how you can put them to market.
So this is actually maybe a good transition. Cameron, what time are we wrapping? Okay, 5 minutes. Okay, yeah, I think it's a good transition maybe to actually the theme of the day, which is the hackathon. I'm curious if you guys are seeing any particular tech stacks, tools, frameworks. Like, what are you seeing in the wild that you think is actually really useful for people to start building and shipping stuff? And are there things on the horizon that you look at and you're like, oh, this is actually going to be really, really cool. It's almost there, or it just got launched and is interesting. So, A, what tools are you seeing startups actually use when you think about the stack? What frameworks? And B, is there something on the horizon that you're looking forward to that you're like, oh, this is super cool and it's going to be really awesome when it launches because it makes it easier to do X, Y, Z for companies? Your thoughts?
Okay, I'll start. Let's see. So this is going to be pure Anthropic shill. Sorry, but if you haven't looked at MCP, you got to look at that. You know, that's like the most important. The most important thing about it right now is that it inverts the control so that whatever your client or agent is, the user can bring their own integration to it. And that's really powerful, but MCP can do a lot more than that. It can offer prompts. It can like kind of dynamically include context. So take a look at that spec. I think if you can find a way to interoperate with that and utilize it, I think it's really powerful. And there's a lot of powerful integrations existing. And then I would say the other thing is like the foundation of an agent is async generator. Your core agent loop is await X for in X's. And Claude code is written in TypeScript and not Python for this reason, because Python async generators are kind of broken when it comes to cleanup. So I have some very specific advice there, but your mileage may vary, of course.
I really like Modal. If you haven't used Modal, like modal.com, it's amazing and lovely and sweet.
Why do you like it? What is it?
Modal is like, this is going to, people are going to hate me for this. It's like Vercel for Python, maybe is like a way to describe it, but like specifically hooks up to GPUs and is very like focused on this. But I think just the experience is like really lovely. And every person who I've ever shown Modal to, afterwards, they're like, oh my God, I love Modal. So recommendation. Yeah.
Any other tools, anything you're excited about on the horizon?
I really like this company called San Francisco Compute. It's a fantastic company. Okay, here is the pitch for San Francisco Compute. If you go to any other GPU cloud and you need a very large amount of GPUs, think thousands, you are going to pay for a long-term contract that is like a year plus, and oftentimes you're going to pay some portion of it up front. We don't do that. We are the only place in the world where you can get like 2,000 H100s or larger for an hour if you want, without ever signing a long-term contract. And that is very nice. So we basically map to your exact utilization, but we don't, our prices are pretty good. So historically, we've had the best prices in the industry as well. And the way that we do that is we work a lot like Hotel Tonight. So we work with all the other GPU clouds and we sell their capacity. So it's all the same people you would have bought from originally, but we sell the ones that are sort of unused in the periods of time. And because of that, we can do these like massive bursts. So if you're doing a big training run, we can get you like much larger scale, something more equivalent to if you had raised the $100 million pre-seed, but without raising the $100 million pre-seed, because it really sort of is hard to do that.
Yeah, and prices are good.
They're really good.
I'm on the page every week to check the prices. So, yeah, I mean, on our side, kind of we see a whole host of problems that people have. We also take a little bit different approach to what we declare an agent. I think kind of generally people take, okay, we're going to have the LLM as a driver, and then it's going to use a bunch of tools. And it works, but it has a lot of limitations, and you kind of, when you want to do anything outside of that kind of simplistic approach, for example, you want to summarize the context for the model because you're running out of context window, et cetera. Now you need to like patch together a bunch of stuff. And so first we kind of take the definition of agent is any Python or TypeScript driver that can use any number of models and effectively any number of tools stitched together, right? So you have the context and you have the environment, you have the file system, you have the browser, and you can kind of effectively, it's more of a computer that has access to LLMs, and now you can do kind of any operation around that. So that's just kind of a little bit of a different mindset from a framework perspective, but it opens up ability to do everything from open up a browser and run an operator in the cloud to running like 5 models as an ensemble and making a decision based on if 3 of them agree. So you kind of have like a lot more flexibility than what normally you get from kind of using just one model. And then the other component is just, as I mentioned, confidentiality. Like I made this point a couple of days ago that users, it doesn't matter how much we say to people that just should care about privacy, they don't. People always will choose convenience over privacy. As a developer, you actually need to deal with privacy, right? You're actually liable for the user's data. You need to be compliant in the GDPR, HIPAA, California data protection laws. And when you go to market with companies are very much so as well under those compliance, and so they need to make sure that you are compliant so they can give you their data. And so that is actually what we're trying to solve. So you as a developer don't need to deal with any of this. You can just upload your model, upload your agents, host them on our platform, and then anybody can come and use them. And neither you have access to their data nor they have access to your models. You effectively have this kind of full confidentiality end to end. And even we don't have access to neither, right? So that's kind of the offering we're working on the really just kind of connecting model developers, agent developers, and the consumers and corporations on one platform with end-to-end privacy, kind of really wide variety of agent use cases.
All right, everybody, thank you so much for coming. Please go use Cloud Code if you're not already. I think everybody here probably is already. Go check out SF Compute. Everybody go check out the Near AI stack. There's really awesome tooling that most people are not yet familiar with that they should try out. And thank you all for coming. Thank you and have fun.